Example 2, derivative of a function given by a table. Let b of t be the population of Belgium at time t. The table at the left down here gives mid-year values of b of t in thousands from 1980 to 2006. We want to construct a table of values for the derivative of this function. So here, again, here's our values of t going from 1980 to 2006. And then b of t is going from 9,000 all the way to 10,000. So if we look at these outputs, we don't see any fluctuations that throw this off. So we assume that since there are no wild fluctuations in the population between the stated values, let's start by approximating b prime of 1988, the rate of increase of the population of Belgium in mid-1988. Therefore, since the definition of the limit that we've seen from the beginning of this section, we are looking at the following formula. So we have b prime of 1988, which is equal to the limit as h approaches 0 of b of 1988 plus h minus b of 1988 divided by h. Now, the second part here is we're going to deal with here. It says b prime of 1988 is approximation. So this means that we're dealing with the smaller values of h. So let's pick the value to be h, which is equal to 2. And then we're going to substitute it into the limit here. So we have b prime of 1988. So that is approximately b of, 1988 plus 2 is 1990. Minus b of 1988 divided by 2. So b prime of 1988 would then be, okay, if we take a look at the output for 1990 and then the output for 1988, so we have 9,969 minus 9,884, and then we're going to divide that by 2, which is equal to 42.5. So what does that tell us? Well, that tells us that this is the average rate of increase between 1988 and 1990. So now let's see what happens when we let h equals negative 2. So when h is equal to negative 2, we now have b prime of 1988, which is approximately b of, well, we know that this is 1988 plus h is going to be 1988 minus 2. So that's going to give us 1986 minus b of 1988. And then divide that by 2. So we know that 1986 has an output of 9,862 minus 9,884. Divide that by 2. And that's going to give us 11. So now what does this tell us? Well, this tells us that this is the average rate of increase between 1986 and 1988. So if you look over here, the 1986 is to the left of 1988. 1990 is to the right of 1988. And so if we want to take a better picture of what's going on between those 3 years, well, we can take the average of those. So what we can do is we can get a more accurate approximation if we take the average of these rates of change. So if we want to find the average of these rates of change, so the average of B prime of 1988, well then that's approximately 42.5 plus 11, and then divide that by 2, which is going to give us 26.75. So therefore, what does this mean? Well, this means that in 1988, the population was increasing at about 26,750 people per year. Because remember that this is 26.75 in thousands to give us that result. Now, if you notice here, okay, if we look at the table, okay, if we take a look at 1988, then we can see that B prime of t is going to give us 26.75. Now, making similar calculations for other values, except that the endpoints, we get the table of the left here, which shows the approximate values for the derivative. Okay, so let's take a look at the graphs of these two. So here's the graph of the function. So this is what the function looks like. Okay, and so this is the first graph, and then this is the second graph. This is B prime. So I want you to pay attention. So here at 1980, we can see that the slope, or the average rate of change, was 4.5. At 1982, the average rate of change was 2. In 1984, the average rate of change was 1.5. And then in 1986, it was 7.25. And then in 1988, which is what we found here at this particular point, we can see that the average rate of change in 1988 gave us a value of 26.75. And so therefore, all of those ordered pairs show you the derivative of this function of this b of t.